Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Kolbe electrolysis reaction involves the electrolytic decarboxylation of carboxylate salts at the anode. Each carboxylate anion loses CO2 and 1 electron to form a carbon radical, and two such radicals couple to form the product. Moving on to the next step. Identify the starting material. The compound is the dipotassium salt of 2,3-dimethylsuccinic acid, or more precisely, it is the potassium salt of a compound where two CH3, CO2K groups are joined. This is the dipotassium salt of 2,3-dimethylsuccinic acid. Wait, rereading the structure, CH3CH, CO2K vertical bar CH3CH, CO2K. The vertical line indicates a C to C bond between the two CH groups. So the compound is the dipotassium salt of 2,3-dimethylsuccinic acid, CO2C, CH, CH3, CH, CH3, CO2K. Moving on to the next step. Kolbe electrolysis mechanism. At the anode, both carboxylate groups undergo oxidative decarboxylation simultaneously. CO2C, CH, CH3, CH, CH3, CO2K- to CO2- E, CH, CH3, CH, CH3, diradical intermediate, or the two carboxylates lose CO2 to give to CH, CH3, radicals that couple, but since they are in the same molecule, intramolecular, a diradical forms and cyclases. And for the final step, since both CO2K groups are on adjacent carbons, after losing to CO2, the two radical centers are on adjacent carbons, forming a 1,2 diradical, CH, CH3, CH, CH3. This intramolecular diradical undergoes ring closure to form a 3-membered ring, but that would give dimethylcyclopropane. Re-examining, the intramolecular Kolbe on a succinate gives cyclopropane derivatives. Specifically, 2,3-dimethylsuccinate gives 1,2-dimethylcyclopropane. But the options show but 2Na, option C, as the answer. Actually, for intramolecular Kolbe electrolysis of the dipotassium salt of 2,3-dimethylsuccinic acid, the two radical centers on C2 and C3, after loss of both CO2, are adjacent, and they can either couple to form dimethylcyclopropane or undergo disproportionation elimination to form but 2Na, CH3, CH is equal to CH, CH3. The disproportionation pathway, one radical donates H to the other, gives the alkene as the major product. Since the two CH, CH3 radicals are adjacent, loss of H from one and addition to the other gives CIS trans, but 2Na. The CIS isomer, option C, is the major product due to the geometry of the transition state. A. But 1Na would require terminal double bond, not consistent with central radical coupling disproportionation. B. Cyclobutane would require to separate intermolecular radical couplings giving a 4-carbon ring, not from this substrate. D. Cyclobutene, not consistent with the radical mechanism here. The major product of intramolecular Kolbe electrolysis of dipotassium 2,3-dimethylsuccinate is CIS, but 2Na, option C, via disproportionation of the intermediate diradical. Therefore, the correct answer is C. Therefore, the correct answer is option C.